Hi, welcome. This is Mrs. Henry. Today we're going to talk about dividing polynomials using two different methods. We're going to start with doing, I think, 3 different examples of using long division, and then I'm going to do 3 different examples of using synthetic division. So let's get started. Here I have 2 polynomials that need to be divided. But if I look at numbers that multiply together to give me negative 43 and added together to give me 3, I know that they are not factorable. So we have to use a different method. So I'm going to go back to elementary school in a long division process. So first we have to divide. So x times what is x squared? And that's x. So we divided. Now we're going to multiply. So x times x is x squared. X times 8 is 8x. Then we're going to subtract. And those cancel, and I get negative 5x. And I'm going to bring down the negative 43. And now we're going to divide again. So x times what is negative 5x? Negative 5. So now we multiply. I get negative 5x minus 40. We're going to subtract all of that. These cancel, and this becomes negative 3. And my remainder is negative 3. So I get, because it's negative, I get a minus sign. 3 over x plus 8. And that's what I get when I divide. So now we're going to do another example of long division. So now I get 2n squared minus 16n plus 19 divided by n minus 7. So n minus 7 goes here, and I get 2n squared minus 16n plus 19. Once again, we're going to divide. N times what is 2n squared? 2n. Then we're going to multiply. I get 2n squared minus 14n. We're going to subtract these. My n squareds disappeared. Negative 16n minus negative 14n. Negative 16n minus negative 14n is negative 2n. Then I bring down the 19. And we divide again. Now we divide again. N times what is negative 2n? Negative 2. Then we multiply. Negative 2n. And I get positive 14. We're going to subtract all that. And my n's disappear. And 19 minus 14 is 5. Because that's positive 5, we get a plus sign. And we write our remainder as a fraction. See how that works? That's fantastic. Now I'm going to try one more. And here I get uh-oh. What happened? I'm missing a term. Every other polynomial has their terms in descending order, and now I'm missing one. What am I going to do? I'm going to need to use that as a placeholder. So I get k cubed, but I have 0 k squareds. Now, notice that this and this are equivalent because I have 0k squareds. But that's going to be very important as we become a placeholder. So k times what is k cubed is k squared. So I multiply. I have k cubed plus 5k squared. This allows me to subtract like terms, so that becomes really important. And 0k squared minus 5k squared is negative 5k squared. And I'm going to bring down negative 17k. And we divide again. So k times what is negative 5k squared? It's negative 5k. I multiply. I get negative 5k squared minus 25k. I subtract. And negative 17k minus negative 25k is 8k. And then I have k times what is 8k? 8. And I get 8k plus 40. And when I subtract, I get negative 8. Remember, it's negative. So my minus goes up here. And I get 8 over k plus 5. So we have completely done long division using divide, multiply, subtract, bring down. Now we're going to talk about a different way called synthetic division. My synthetic division looks like this. Starts out the same. I get x squared plus 3x minus 43 divided by You may be thinking we just did this problem. You're right, we did. But now I'm going to show you how to do it synthetic division wise. We're going to start with what we're dividing by over here. And we're going to set that equal to 0. So x equals negative 8. I'm going to put negative 8 in a box over here. Now I'm going to bring down the coefficients all over here. And I like to put a dot here because my last term is always going to be my remainder. So first of all, we drop down our 1. We're going to take 1, multiply by negative 8. That goes here. And then we're going to add. So 3 minus 8, or plus negative 8, is negative 5. And now we're going to multiply again. Negative 5 times negative 8 is 40. And we're going to add here and get negative 3. We started at x squared and divided by x. So 2 minus 1, this is our x term, this is our constant, and this is our remainder. So our answer becomes x minus 5 minus 3 over x plus 8. Let's practice this one a couple more times. So if y minus 2 equals 0, y equals 2, and that goes in the box over here. And we start by, remember, bringing our coefficients. This is 1, this is 5, this is negative 7, and this is positive 2, leaving our spot for the remainder. We drop down the 1. 1 times 2 is 2. We add these together. 5 plus 2 is 7. Then we multiply. 7 times 2 is 14. We add them together and get 7. And then we multiply. 2 times 7 is 14. Then we add. This time we started with x cubed and we divide y cubed and we divided by y. So 3 minus 1 is 2. So this is my x squared, x constant remainder. So I have x squared plus 7x plus 7 plus 16 over y minus 2. We're going to try one more example here. Here, notice we're missing an x squared term. So in order to make this work, we're going to have to put in 0x squared. So we'll start again with x minus 8 equals 0, and x equals 8. And the 8 goes over here. And we're going to write our coefficients, but remember, we have 0x squared here. So we can't forget that. I have my coefficients of 8, negative 64, 0, 3, and negative 28. I'm going to drop down my 8. 8 times 8 is 64. Add them together, 0. 0 times 8 is 0. Add them together, 0. 0 times 8 is 0. Add them together, get 3. 3 times 8 is 24. Add them together, you get negative 4. Now here we started with x to the 4th and divided by x. So 4 minus 1 is 3. So I get x cubed, x squared, x, constant in remainder. And my answer is 5x cubed plus 3 minus 4 over x minus 8. And then I'm done. Until next time, kiddos. See you all later.